Hi, my name is Ingrid and I'm going to solve the exercise with my own values. So we have this beautiful circuit right here and we are going to do it by the mesh method. So we are going to start the analysis. We have here a super mesh. How do we know that's a super mesh? Because of this thing right here, there is a current source, and yeah, we know that because we have the current source here and it's uniting these two meshes. We're going to also do this. We're going to determine the flow. We're going to do it clockwise because it's easier and I didn't want to complicate myself with these things. So yeah. Oh, sorry. And we're going to do first just the analysis. So we have here a resistance, 55 ohms. It doesn't really understand it, but it's ohms, okay? I just can draw really well. So the flow is positive because we decided that it was going to be positive. So current 3 minus current 1. And the next is resistance as well. And it's going to be 54 multiplying by the same analysis we did here, or with the second current. So we have the flow, we have this resistance, it's going to be 64 multiplying, but it's just one current, so it's just I4, sorry. And all of this equals 0. Now mesh 1. So we have a voltage and power source. So it's minus because of the polarities. And the same that we did here, but with this one. And also we are going to do this one. In this case, we are using current 1, so this one is now the positive, and the other one is the negative. Sorry, there was a flaw or something like that. So, and also this one. Also voltage, but it's now positive. It's the same analysis as this one, so I'm not going to explain it again. Now, also we have a relation. Why? Because it's super mesh. Amazing, isn't it? So, we can state that this is equal to decompose these two currents. So it will be like it's just because of the flow, okay? That will be current 4 minus current 3, and this equals to 1/4 ampere. Just not 3 ampere, and that's right. Now we're going to put all of these amazing 4 equations in our amazing calculator. Obviously, simplify it. So you will have to believe me that these were my results. So we have the results, and we want to know what Bx is. Easy peasy lemon squeezy with Ohm's law. The same thing we were doing here. So, well, Bx it will be equal to 55 multiplying. We now have the values. Just want to evaluate, and it will be this thingy minus, but algebra. So plus this thingy. And again, our amazing calculator will tell us, don't remember, wait a minute, it tells us this is our result. So we now know the voltage. Now, the potential in here, it's always easy. So as we stated before, we can treat this as a resistance as well, and because they are in parallel. So what we know that they have the same voltage, so it will be, we're going to put a 4 here because it's my 4, and resistance 4 is just this one, right? Around here, multiplied by the current, and we now know the current. And this amazing operation will tell us if it's regenerate or consume. And put it on the calculator, okay? I just don't want to see it right now, and I put it on my hand, so it's easier. And it's positive, that tells us that it consumes. Amazing, thanks for watching. Bye.